Properties of exponents, example 1. When you multiply two expressions that involve exponents, you want to start by multiplying the coefficients. So we say 2 times 5 is 10. When you multiply like bases, a times a squared, we add the exponents to get a cubed. B cubed times b to the 5th would then be b to the 8th. In example 2, we have negative exponents. So this is the first time we're seeing negative exponents. The easiest way to deal with negative exponents, in my opinion, is to create positive exponents by moving them from wherever they are. We have a v to the negative second. Since it's in the numerator, I'm going to slide it down and it will become positive. I have a u to the negative first, which is in the denominator. I'm going to move that up, so that will become positive. So now I have u squared u to the first. In the denominator, I have v cubed v squared. In other words, I have u cubed over v to the 5th. Remember, the only term that you move is the term with the negative exponent. Example 3. We now have two expressions we're going to multiply together. The easiest way to do this is to simplify each expression individually and then multiply them together to have one fraction. There's multiple ways you could do this, but that is how I'm going to show you today. So when we have a power to a power, x squared raised to the negative third, you multiply. So for your first fraction, that becomes x to the negative 6th over 2 to the negative third. My second fraction, when I take a power to a power, I have 6 to the first to the 5th, which is 6 to the 5th, x to the negative 15th, y to the 40th, over x to the negative 10th, y to the negative 10th, z to the positive 5th. So we have a lot of stuff we can do here. When I put it as one fraction, I'm going to simplify this to one fraction. I'm going to multiply straight across the numerator and straight across the denominator. When I multiply straight across the numerator, my coefficient is still 6 to the 5th, which is 7,776. X to the negative 6 plus negative 15 is negative 21st power. And I still have a y to the 40th in the numerator. I'm going to multiply straight across my denominator. That's going to give me 2 to the negative third. I'm going to keep it like that for now. X to the negative 10th, y to the negative 10th, and z to the 5th. Now I'm going to work on all of these negative exponents. I'm going to take this guy, move him up, so that he becomes positive. 2 to the negative third in the numerator will be 2 to the third, which is 8. So now I'm taking 8 and multiplying it by 7,776. So my numerator, I'm going to work up here at the top of my screen. My numerator is now 62,208 is my coefficient in the numerator. I notice I could move x to the negative 10th up to make it positive, but I also have x to the negative 21st in the numerator, and if I move that down, I'm going to be adding 21 x's to the denominator. And since I have negative 10 down there, when I add positive 21, that is going to give me a positive exponent of 11. So if you wanted, you could move the x to the 10th up, the x to the 21st down, and then use your subtraction rule. Or you could use your subtraction rule from here, saying x to the negative 21st minus negative 10, which would give you x to the negative 11th in the numerator. To make it positive, you would then drop it to the denominator to make it x to the positive 11th. So whichever method of thinking makes more sense to you. I also have some y's I have to deal with here. I have y to the negative 10th. I'm going to move that up and combine that with the 40y's I already have in the numerator, which is going to give me y to the 50th. I don't need to do anything with z to the 5th, and I have nothing to combine it with in the numerator, so that stays z to the 5th in the denominator. And this here is my final simplified answer. Again, I just want to reiterate that there's numerous ways you could do all three of these problems. So if you're still having questions, please come and see myself for some extra help.